Hello everyone. In this video, we will create a Simulink model to simulate continuous, hybrid, and discrete systems. To launch Simulink, go to Home tab and click on Simulink icon. In this case, we will create a blank model. We will first create a unit feedback continuous time control system. We will enter the component starting from step function. Click on the library icon. The library browser will open up. In the source category, you will find the step block. You just drag and place it on the blank model. Set up the start time at 0. You can also configure it later, for example, step time, initial value, final value, and sample time. Now let's enter the summation box. In the math operation category, drag and place the summation box. Because this is a negative feedback system, we need to change the feedback to be negative. Now the transfer function for the lead compensator. In the continuous category, you can find the transfer function block. Drag and place. As you can see, if the two blocks are aligned, the Simulink can add the arrow automatically. A quicker way to enter a block is to click on the canvas and enter the name of the block. For example, transfer function. You will see after typing a few letters, the transfer function appear, and then click enter, the block will be placed. If you drag and align two blocks, you can see an arrow shadow. Click on the shadow, the arrow will be placed. Now, enter a scope, click on the canvas, and type in scope, click enter, a scope will be placed. Or you can find the scope in the sync category of the library browser. Place all the arrows to complete the block diagram. Specify the coefficients of the transfer functions. Let's find the coefficients of the lead compensator in the MATLAB command window. Now double-click the block and enter the coefficients for the numerator and the denominator. You can also use variables to configure the coefficients, for example, K0, A, and B, as long as they exist in the workspace. Similarly, enter the coefficients of the numerator and the denominator for the plant. You can use the scroller on your mouse to zoom in or zoom out the diagram. Hold the space, you can drag around the diagram. Set up the simulation time, in this case 1 second, and run the simulation. Double-click on the scope, the simulation results will show up. Let's enter the block diagram for a hybrid control system. Copy and reuse some of the blocks. Delete the continuous time transfer function for the compensator and replace it by discrete time one. The discrete time transfer function can be found in the discrete category in the library browser. This is a hybrid system. We need a zero-order hold to interface the discrete time compensator and the continuous time plant. Find the zero-order hold in the discrete category. If you don't place a zero-order hold block, Simulink will imply one. In other words, it will place one for you implicitly. We now need to specify the coefficients of the numerator and the denominator of the discrete time transfer function. The coefficients can be found in the command window because we have run some MATLAB scripts early on. dz is the transfer function from which we can find the coefficients, but a better way is to use the variables obtained from the tfdate command. Let's use the two variables num.dz and din.dz to specify the block. This way, even the sample time changes, you don't need to modify the Simulink model. Instead, you can just quickly rerun your MATLAB script, and the variables in the workspace will be updated. We also need to specify the sample time for the discrete time compensator, t equal to 0.01. A better way is just to use t. Once again, if t changes, you do not need to come back to change this setting. Let's connect the output of the hybrid system to the scope so that we can see the simulation results simultaneously. Delete the connection with the continuous system. Right-click on the scope. Change the number of the input ports to be 2. Connect the output of the systems to the inputs of the scope. Double-click on the lens. Label the output signal of the systems so that we can differentiate the simulation results in the scope by using a legend. Run the simulation by clicking on the green arrow icon. Double-click on the scope to see the simulation results. Add a legend in the review menu so that we know which signal is which. Now let's create a pure discrete time system. Copy and paste some of the blocks. Delete the zeroed hold block. Replace the continuous time transfer function of the plant by a discrete time transfer function. And specify the numerator and the denominator of the discrete time transfer function. We have used the C2D with zeroed hold method to convert the continuous time plant to a discrete time plant. We also use the TF data to create the variables for the numerator and the denominator of the discrete time plant model. We will use the two variables to specify the discrete time plant transfer function. Also, don't forget to set up the sample time. Change the number of input ports of the scope to 3. Connect the output to the scope. Label the output signal. Run the simulation and see the results. Try different sample times specified in the lab handout. Compare and discuss the simulation results in the library part. The best practice is to create a MATLAB script and use variables in the Simulink model. Then you can change the sample time t, run the MATLAB script, and all variables will be updated based on the new sample time t. Because the Simulink model are specified by the variables, you do not need to change the model anymore. Just rerun the Simulink model. You will see the updated results. Alright, thank you for watching. See you next time.